Hi, Sam Roberts here from Roberts Geospatial Engineering. Today I want to show you the GLO-30 digital surface model. It's a terrain dataset for the entire globe, for the whole Earth, at 1 arcsecond resolution, which is about 30 meter resolution. It comes from the European Space Agency and it's derived from WorldDEM. And I've downloaded this dataset and merged the individual tiles, which are 1 by 1 degree tiles, and turn them into an MRR format raster, which we're going to take a look at. So on my website, if you go to resources and articles, you'll see there's a new article called GLO-30 in MRR format, and there you'll find a description of the work, and I recommend that you download this as a PDF and you can check it out. So there were 4 files created. Now 3 of them are available for download. So if you go to the resources data page on the Roberts Geospatial website, you'll see here the GLO-30 DEM and masks. So I have the water body mask, the filling mask, and the editing mask available there to download. The actual terrain data itself, the DSM, is not available. It's a 173 gigabyte file. And as soon as I figure out how to upload that thing to the cloud, I'll get it up there and you'll be able to download it. It comes from the European Space Agency. Here's the Copernicus page where you can find all the details. You can find the licensing and so forth. And there's a handbook where you'll find all the information about the data sets. So I'm going to run ProRaster Scientific and have an algorithm here which we're just going to use to display all of these data sets. Now, so just as a reminder, we have the digital surface model. This is the terrain data. There's a water body mask, and this is a classified raster that maps all of the land, all of the rivers. I should go to a river. Where can we find a nice river? Here's the Mississippi. Maps all the land, maps all the rivers, and maps all the lakes. So it's a classified raster. And then you have the filling mask, and this tells you in each pixel in the raster whether they've used the TanDEM-X terrain data, which is the predominant source, that's the key source, but where they don't have good data, it's filled from other data sets. So it might come from SRTM or ASTA or anything. So for example, here we're getting SRTM-30, whereas these ones are not filled, not edited, so they're coming from the TanDEM-X, and most of it is green, as you can see, but particularly in things like the Himalayas, you'll see there's a lot of fill from different data sets, SRTM-30+, this one's GM-TED, and so forth. Then you've got the edit data mask. So this tells you how things were edited, what was actually done to the pixels, and then again, if you zoom in, you can see that these are infill of external elevation data, whereas these green ones are not edited. So that's the 3 masks, and then our terrain data there. So let's go full screen. We'll put that over there. I'll turn off the webcam. We don't need to see my head. Oops. So here's the data set. So let's turn off our tooltips and we'll go exploring. So as I mentioned, this is a 1 arcsecond resolution data set. So it's about 30 meter across the entire globe. So it goes from pole to pole. Here we're in popular CRS projection, so we're only seeing down to about 85 degrees, but the data set extends right to the poles north and south. Of course, there's nothing at the North Pole. And so if we zoom right in, you can see that it's high resolution data, some of the best data available in the world. The WorldDEM dataset is now shipped as WorldDEM Neo by Airbus. It was originally at 12 meters. It's now shipping at 5 meters. And they ship both a digital surface model product, which is like this. Now that has trees and buildings and so forth in it. And they also ship a digital terrain model product, which is supposed to be the ground surface, where they've removed the effects of trees and so forth. So maybe we'll look at that first, and we'll perhaps come over here to Australia. And if I zoom in here to around the Murray River somewhere, you can see as I come in, there's these artifacts. These are roads, of course, and there's a bit of a hill. It doesn't matter, I'll just come in here. So if I push this view out to 3D, I'll come over to my control here on ProRaster Scientific, turn on the imagery, and I'll push this to a 3D map, bring that in from the other screen. I just want to set up my map settings here. Scaled, okay, 20. Alright, so if you look at this, you can see that there are anomalies all over, terrain anomalies all over the place, and they're in straight lines. They follow the roads. And so these are the trees in the data set coming out as terrain anomalies. So, and you'll also find buildings create anomalies, large buildings. It needs a fairly large footprint to have an effect, but you'll see that all over the place. So that's one of the negatives of this data set. I don't want to harp on about the negatives because it is completely free. It is probably the highest quality and highest resolution free global terrain data set that you can acquire. So let's just take a look around the world. Perhaps starting here in the United States. I'll go to the pan fly mode. Of course, we have the Grand Canyon, and coming up the west coast, various mountains. And if you come in to these things, so you can explore them and push them out to a 3D map. We'll do this periodically as we fly around. So here's our 3D map, that particular mountain. Turn on the Google Maps overlay, we can find out. So that's Mount Shasta. Okay. Fly around a little bit. This one is that's got a very recognizable shape. That's Mount St. Helens. And of course this larger one would be, I guess that's Mount Rainier. But there's Mount Rainier. Going up to Alaska, we can find Denali. Is this Denali here? I think it is. On the overlay again. Oh yeah, that's Denali. Lots of nice glaciers all around it. There's Mount Denali. Oops. Nice looking peak. So in terms of detail, there's a fabulous amount of detail. Let's go over to Africa. So here we are in North Africa with this amazing circular feature. I think that might be a meteorite impact, but I'm not sure about that, and I'm not sure people are very sure about it. But you can see the detail in the sand dunes, and you can see some other things. So perhaps here you can see this. So we have sand dunes coming through, and then there's this feature here which happens to go in exactly the same direction as the satellite. So this is a filling or editing feature. So if we go back to, say, our fill mask, turn that on, and you can see now. So this is filled with GLO-30 whereas these green pixels are not edited, not filled. So they're coming from TanDEM-X mission. And then this is filled from another mission. Here's another section over here. So it's got some data coming from ASTA, GLO-30, and then up here it's SRTM30. Turn that off. And you can see clearly in the terrain data that boundary between the good data and the data from other rasters, other data sets that may not be as high quality. But in these sand dunes, you can see really amazing detail. You can see that the major set of sand dunes running here to the northeast, but then there are these additional little sand dunes which sort of running at a slightly different angle. Perhaps we can, now to do a profile, I just need to highlight that, and then we'll draw a profile. So if we go across, you can see the major sand dunes, and then these other little bumps are the other sand dune features that are at slightly different angles. So if we come across here, you can see these other little features only a few meters high. You know, that's really only a couple of meters high perhaps. So there's a lot of detail in this raster. Let's fly around a little bit. Here we are in, I think this is Niger. Have these really interesting circular features. Middle of the desert, you get this kind of big circular mountain, or plateau really. Here it is in 3D. Oh, we've got a bit of scaling. Put it on unscaled. There's that feature in 3D. Just a round plateau out in the middle of the desert. I guess these cracks in it all follow the geology. I imagine they're probably granite intrusions or something like that. Talking about circular features, let's go hunting for some meteorite craters. I know there's one down here. This is in South Africa. Don't ask me to tell you what the name of it is. There's one. A little meteorite crater there. Let's have a look at that in 3D. So you can see that's a real sort of hole in the ground. It's been dug out well below the surrounding level of the plain. Got some exaggeration there. That's a 4 times exaggeration vertically. That's South Africa. Of course, there's the one in the US, isn't there? So we go across to the US. I think it's called Meteorite Crater or something, isn't it? I don't know. Forget. It's somewhere around here. There it is. That's a nice little feature. And there it is in 3D. Again, a real sort of hole in the ground. Dug out by a nice little impact. I think I've looked at this one before in a previous video, but there's one in Australia. And there it is. It's quite easy to find in this data because it's really got a very low level of noise. You can find topographic features quite easily. A little crater. Oops, grab that. And you can see some sand dunes running alongside it there. And again, dug out below the level of the surrounding plains, but not quite so much. We've got a lot of exaggeration there. That's 8 times. And there's a little feature in the middle. I think that's just a little lake that's sitting in the base of the crater. So that's talking about holes in the ground, is a spectacular hole in the ground up here. So up here in Papua New Guinea, here on the western side, which I think this is Indonesia, and so this is up around 4,000 meters or more. Actually, the highest peak in Asia is this one here, and it's called Puncak Jaya, I think. Yeah, Puncak Jaya. So that's the highest peak in Asia. But this thing here is the Grasburg mine. It's a giant copper and gold mine, sitting around, at around 4,000 meters. Let's turn contours on. There it is. So yes, at around 4,100 meters here, 4,300, 47. This would be Puncak Jaya here at around 4,800 meters. Let's take a look at this one. So Grasburg, copper gold, giant open cut pit, as well as, now this time we need to up the scale because we're at 0.5. Also underground operation, I believe. And you can see the roads here going down into the pit. So that's Grasburg. Big hole in the ground, very high in the sky. So there are a few problems with the data. One of the things that I found interesting, let me go to the water mask. So this is just telling you where the land is, where the water is, and where the rivers are. And you go over to northern Canada, and you can already see northern Canada is absolutely full of lakes. You can't walk 3 meters without falling into a lake. But in this data, the lakes are in stripes. So between these stripes, they've missed out on literally hundreds of thousands of lakes. So that's a big fail with the water mask. I don't know what they've done there. Apart from that, it looks pretty good. But that's one of the issues. Another issue I noticed pretty quickly out here in the Pacific Ocean, middle of nowhere, is Lord Howe Island. And so here's Lord Howe Island, and something's taken a big chunk out of its arse here. The shape of the island is actually wrong. We're missing a section on the southwest corner, and there's a big mountain here which is missing. This is a huge big mountain and quite rugged, very rugged, and it's just not there. So we've had an editing fail there, and related to that, out here is Ball's Pyramid, and you can see that it's about 1 metre, getting up to 17 metres above sea level. Well, in fact, Ball's Pyramid is about 572 metres above sea level. This thing is a pinnacle sitting out in the middle of the Pacific Ocean, and it's vertical. It's absolutely spectacular, one of the most spectacular features in the natural world, really. But you can see that it has been completely excised from the data. The footprint is still there, but the thing has been removed. So I imagine they've got some spike detection and removal algorithms, and it's removed Ball's Pyramid perfectly. So their algorithm's working, but it's just a pity that they erased one of the world's most spectacular topographic features. And related to that, I noticed that Mount Everest doesn't have the right height. It's always so hard to find Mount Everest. Actually, I think that's it there. Let me turn on the contours. Yeah, so here's Mount Everest. So if we come from over here, here's base camp. You come up this glacier, jog, and then you climb up this steep ass wall, and you come up to the South Col, and then you climb up this way over the Hillary Step, and you get up to the top of Mount Everest. And you can see from the contours that it's at about 8,740, which is a full 110 metres short of the actual height of the summit. So they've chopped off the top of Everest. And if you look at the filling mask, and I turn on our tooltip, so it's come from SRTM30 plus. So they're using SRTM30 plus for Everest, SRTM30 out here, and this is TanDEM-X. But for whatever reason, they've had to fill in. Take those contours off. They've had to fill in quite a lot of this region from other data sets, and clearly they're not particularly good. And there's a lot of filling all across the Himalaya in particular. So that is GLO-30. So I think it's a fabulous data set. It does have some problems, it does have some errors, but it is free, and from that point of view, you really can't complain. It is full of trees and buildings. Where can I show that? Oh, we can illustrate that down in New Zealand. So here's Mount Taranaki on the west coast of the North Island of New Zealand, and you can see there's this round circle around the peak, and that represents farmland on this side where there's no trees and lots of sheep, and on this side there's trees, and there's sort of a gap between them. Maybe we can draw a profile across there to illustrate that. Profile. Let's go across there. And you can see that it goes bonk down there, drops about 15 meters as you come out of the forest and into the farmland. Band fly mode. Mount Taranaki. You can go glacier hunting. So for Australians, these are spectacular glaciers. You know, we go over to New Zealand and this is Mount Cook, the highest mountain in New Zealand, and this is the Tasman Glacier, I suppose. And then over the other side, there's these other little glaciers. I guess this one is this one would be the Franz Josef Glacier, I think. Don't quote me on that. Anyway, at this scale, they look quite small. When you get there, they're absolutely spectacular, but of course they pale into insignificance compared to glaciers in the Himalaya, or I was going to go back over here to Alaska, where your glaciers are absolutely spectacular. Rivers of ice. Amazing detail and plenty of things to explore, and that's one of the focuses of Pro Raster Scientific, or Pro Raster. It's designed to be able to explore data, explore huge data sets that are otherwise difficult to explore, and have this sort of perspective on the world as a whole, and to be able to fly anywhere in the world and compare things and measure things. So, for example, how wide is this glacier in Greenland? It was 4,208 meters wide. Actually, I find that confusing. It's because we're so close to the pole. Anyway, we won't dwell on it. That's an issue for another day. Anyway, so go back to my website where you'll find the masks and in future, hopefully, the data set itself. And of course, you will need Pro Raster to read these MRR files, or map info. I think that might be a meteorite crater in the middle of India. Not really sure. Maybe it isn't. It doesn't have... Nothing's been dug out of the plain, so maybe it's some kind of geological feature. Lots of things to find. I commend it to, and I hope you enjoy it and get something out of it and make good use of this data set. Thanks for watching.